Again, with h of x, we're going to try and graph it. So first find the zeros, which means taking the numerator x squared minus 4 and setting it equal to 0. We can factor that into x plus 2, x minus 2 equals 0, and we see the two zeros happen when x is either negative or positive 2. In the second part, identifying the vertical asymptote, that comes from the denominator, x plus 1. Our x plus 1 can't be 0, so that means that x can't be negative 1. The domain then is that x is not equal to negative 1, but the vertical asymptote is the line x equals negative 1. When we're trying to find a horizontal asymptote, we would just take the limit as x approaches infinity of h of x. And that would simplify to the limit as x approaches infinity of just this part of the fraction, the x squared over x, which is x. But letting x approach infinity, x will turn into infinity. And that would mean that we'd have a horizontal line at y equals infinity, which we can't ever really draw. You can't ever get to infinity. That's why there's going to be an oblique asymptote, not a horizontal one. And the only way to find that is going to be through this long division. When we do long division, we're going to just kind of focus on this first term and ask ourselves, what do I need to multiply this x by to turn it into x squared? And that, of course, is going to be x. So I'll go back and multiply the entire expression by that x, getting x squared plus 1x. Now we subtract the entire expression. X squareds cancel, and 0 minus x is negative x. Bring down the minus 4, and ask ourselves again, what do I got to multiply this x by to turn it into negative x? And that will be minus 1. So minus 1 times x is negative x. Minus 1 times plus 1 is minus 1. So we'll go back and subtract that. The two negative x's cancel, and negative 4 minus negative 1 is negative 3. That's our remainder, so we're left with a remainder of negative 3 over x plus 1. And the thing about that is that when we're thinking about the range, negative 3 over x plus 1 could never equal 0 because the numerator is not equal to 0. And that means that x minus 1 minus 3 over x plus 1 could never equal, since this part could never be 0, the entire expression could never be x minus 1. Therefore, our oblique asymptote is going to be the line y equals x minus 1. So let's put it all together and graph it. First of all, our two zeros happen at negative 2. Let's see, there's negative 1, 0, 1, and positive 2. Those are the two x-intercepts. Our vertical asymptote happens when x is negative 1, so I'm going to draw a dotted line there. Our oblique asymptote is a line y equals x minus 1. So I'm going to need my y-axis. So I'll draw that in at x is equal to 0. Then for the asymptote, I need a y-intercept at negative 1 and a slope of up 1 over 1. So my oblique asymptote will be this diagonal line. Now that the asymptotes are done, I'm going to go back and do a sign chart. In order to do it well, I'm going to factor h of x into x plus 2, x minus 2 over x plus 1. Then take each interval. First, I'll pick something extraordinarily negative, like negative a billion, and negative a billion plus 2 is negative, negative a billion minus 2 is negative, negative a billion plus 1 is negative, making the entire fraction negative. Pay attention now to where the intervals are. Our next interval is going to start at the 0 and go over to the vertical asymptote. So it's just going to be this part. And if I pick something in between negative 2 and negative 1, that'd be like negative 1/2. It would turn this one factor into being positive right here. Otherwise, negative 1.5 minus 2 is still negative. Negative 1.5 plus 1 is still negative. So our entire fraction has become now positive. The next interval, pay attention, it starts at our vertical asymptote at negative 1 and extends over to the 0. Now, not the 0 of the asymptote, but all the way over to the 0 of our function. That's kind of important to notice. We're going to pick a number on that interval, like 0, and plug it in. 0 plus 2 is positive, 0 minus 2 is negative, and 0 plus 1 is positive. So that means that our Every number on this interval, positive, positive, is going to be negative. Lastly, we'll pick something extraordinarily positive, making every factor positive, so the entire fraction is positive. The last step is to graph it. Starting on the left interval, it's going to begin at the 0, be underneath the x-axis, and approach our asymptote. The second interval, it's going to go from that 0 and become positive and approach the vertical asymptote. So we're looking at a branch that looks like this. After we cross over our vertical asymptote, it's going to be negative, so below the x-axis, and actually below our oblique asymptote, and getting closer to the vertical asymptote. Finally becoming positive and getting closer to our oblique asymptote. So we have a sketch that kind of looks like this.